Hey everyone, welcome back. Today I have something very special in store for you. We're going to talk about a sieve that belongs to this ancient Greek guy named Eratosthenes. So, 5 syllables. Eratosthenes. Oh, that's 4. Never mind.
That's 5. Eratosthenes?
Oh, never mind. I was right the first time. Jordan, how do you feel about that word?
It's a long word. It's a long name.
How does it make you feel?
It makes me feel neutral.
Neutral.
Yes.
Oh. Well, I want you to say Eratosthenes, but with a sense of showmanship.
Eratosthenes.
Yes, Eratosthenes. When you say that word, it makes you get up and feel like you want to do something with your day, doesn't it? Do you concur over here in the corner?
Oh yes, Eratosthenes.
The Ness, like the video game character Ness?
Ness.
Okay.
Eratosthenes.
Yes. I agree. The very word itself, it when you say it, you can't help but feel like you have to say it with a sense of grandeur. You can't help but say it with a sense of panache. Panache. Yes, panache. That's what I said.
Panache.
Panache. P-A-N-A-C-H-E.
How do you spell that?
Panache?
I just did.
Oh,
P-A-N-A-C-H-E.
It's like pan and ache.
Oh, okay.
Yes.
Pancake, but pan ache.
Nick.
Yeah, precisely. Precisely.
Was Eratosthenes a man of royalty back in the day?
He was the director, dear sir, of the Library of Alexandria.
Oh,
Okay?
wow.
And he happened to be second best in almost everything. He was a
Oh,
jack of
wow.
all trades.
Wow.
He could do it all. Yes.
Only second.
But
Oh.
I believe that second best in many things is better than first in one thing.
There's no glory in second.
Yeah. Well, I agree to disagree that never mind. I don't know what that meant. Anyway. So, what was his contribution to math? Well, remind me, what did we say last time about composite number A? If A, and of course a natural number, is composite, what does that imply about the square root of A?
That the numbers under the square root of A divide into A?
There has to exist
A P, a prime
a
number.
P. So I should have started with that. There exists a prime factor P such that this right here is true. P is sandwiched between 1 and the square root of A, and it can be equal to the square root of A. Now, in other words, P has to divide A. Well, if P divides A, that's just another way of saying that A is a blank of what? Of P.
A factor?
No, P is a factor of A, just like 3 is a
So
factor
A
of
is
6.
a multiple of
Yes, A is a multiple. A multiple of P. Now the genius of Eratosthenes was in taking this monstrosity here, this beautiful monstrosity, and contrapositivizing it. That's a word I made up, but it makes sense. If it's not a word, it should be. Tell me, what is the contrapositive of this statement?
If A is not a multiple of P, then there does not exist a factor in A.
There doesn't exist a prime factor P
A prime factor P.
between, or such that this inequality holds true. And if this inequality doesn't hold true, what does that imply about A?
A is prime.
A is not composite, and if it's not composite, it has to be what kind of number, the miss in the corner? Oh, Mr. Cookie is quite scared. Oh, I'm sorry, dear friend, little creature of the earth. But you, the creature that can speak, what is A? If it's not composite, then by process of elimination, if it's a natural number, it must be what?
It starts with the letter
P.
prime.
Yes! P-R-I-M-E-E. Or no, just one A. A is prime. So, he got that in tow. And also in tow, he realized this. Let's put that over there. So we'll star that little fella there. We'll have another starred little fellow here. And where was I going with this? Oh, yes. Let's let the square root of a, where a is a natural number. Let's let this be 1. But let's just list out the prime. P1, P2, comma, dot, dot. Let's say all the way up to P. And now these don't necessarily have to be factors of a by itself. Let's just say these are just the prime numbers between 1 and the square root of a. For example, the primes between 1 and 10 are what?
1.
No, 1's not a prime.
2, 3, 5, and 7.
Yes, 2, 3, 5, and 7. Are all of those factors of 10?
No.
But what has to be true?
One of them has to be a factor of 10.
Yeah, one of them has to be a factor of 10 because 10 is composite. So, in that vein, let's conclude that, let's see if we have some natural number b. The b belongs to the set of this bad boy there. And let's say b is less than a.
What is that set you drew? Set of natural numbers?
Yes, this exquisite looking letter stands for the set of natural numbers.
Okay.
Okay.
Cool.
Have you seen that before?
Never.
Never. Well, it saves on space, so we'll.
Okay.
It's good to learn a lot of this thing here. Now, if b is less than a, what has to be true about? Before we go there, by this then, by the previous argument, we know that P1 or P2 or all the way up to Pm has to have what relation to A?
Has to be divisible by a.
Has to, divided.
Yes.
In other words, A has to be a multiple of at least one of these things by the previous argument. Well, if A has to be a multiple of one of those things, and if B is less than A, then the square root of B also has between here either P1 or P2 or P3 or Pn. It might not have Pn, but it definitely has to have
one of them.
One of them. For example, so we can say, okay, so let's write this out first. So for example, this big thing of numerical soup here. What is the square root of 100?
10.
10, yeah, that's why I chose 10. What are the prime numbers between 1 and 10? Mr. Jordan?
2, 3, 5, and 7.
2, 3, 5, and 7. Is 100 a multiple of at least one of those things?
Yes.
Yes. Now let's pick a number on the way down here, but still bigger than 10. Let's say 24.
Okay.
The square root of 24 is about how much?
4.9.
4 point something. What are the prime numbers less than 4?
2 and 3.
2 and 3. Is 24 a multiple then of 2 or 3 or 5 or 7?
2 and 3.
Yeah, 2 and 3. So still, 2 is a multiple of either 2 or 3 or 4 or 5 or 7. Yes?
Yes.
So with this in tow, we know that if any number in here is composite, it needs to be a multiple of
2, 3.
Yes, speak
5 or
fine.
7.
5 or 7, exactly. So, if it's composite, it has to be a multiple of that. Which means if it's not a multiple of 2 or 3 or 5 or 7, it is what kind of number?
A prime number.
It's a prime number. Let's start with the low-hanging fruit then. Let us figure out what our multiples of 2 are that are composite.
It's every even number.
Alright. Yeah, you come to the board and cross them off. I'm getting.
You didn't tell me to dress up. I'm in my tank top.
No, you are quite a.
Thank you.
Quite a specimen of human
So
beauty.
first we got 2's a prime number, so I shouldn't cross that out. I'm gonna cross out all the composites that are multiples of 2. So that goes by. All that goes by.
Yes.
All that goes by, and all this goes by.
Like fish in a barrel, they are going away.
Yes. And now we gotta look at the multiples of 3 that are odd because we already got
The last column, 10.
Oh yeah, thank you. Got that out too. And now we're gonna look at the multiples of 3 that are odd because we got the even multiples of 3 out. So what I'm gonna do is I'm gonna start from 9 and add 6. So 9 is out, 15 is out, 21 is out, 27 is out, 27 plus 6 is 33, then 39, then 45, then 51, then 57, then what's 57 plus 6? 63.
63.
Then 69.
69.
Then 69 plus 6 is 75. 81, 87, 93, and 99. And I believe that's all the multiples of 3 that are out.
Good.
And now 5.
Alright, good job. Don't steal my thunder, sir.
Alright, won't steal your thunder.
Alright. Multiples of 5 remaining. What are they?
25, 35. I can't see the board, you need to.
55, 65, 95, 85.
Okay.
Right?
You said 95, then 85, but oh well, it's okay.
It is okay. You know why it's okay?
Why?
Because I did it.
Okay.
That's what, by definition, it's okay. I'm the truth maker of these things. What is what are the multiples of 7 that are remaining?
The ones that are remaining, I know that 49 is still there. 28 we already took out. What else? 91, I know that's 1. And there's one in between somewhere. 77. Yeah, 77.
Good job.
And I think that's it.
Oh, let's run them down. 3, 5, 7. Of course, those are prime. 11, 13, 17, 19. Any peculiar boys here? 23, 29.
31, 37, 40. Yeah, that seems good.
These all look good. This is the sieve of Eratosthenes. A sieve lets certain things through. It doesn't let other things through. The sieve let what kind of numbers through?
Prime numbers.
No. It let.
Everything except the prime numbers.
Yes. Or you can think of it either way.
So how come 1 is not prime?
1 is not prime because how many factors does 1 have?
1
Just
and 1.
one.
Just 1.
Okay.
And that is the great contribution of Eratosthenes. Everyone say it with me.
Eratosthenes.
Great.
Good job. Is it over?